Hey guys, this is Mr. Grice for Algebra 2, Chapter 4.6 Notes, Part 1. Today we are talking about introductions to relations and functions. Our learning target today is to be able to determine if a relation is a function, to be able to identify the domain and range of a relation, and to be able to apply the vertical line test to determine if a graphed relation is a function. So, we are going to have a couple of vocabulary words that you guys need to go ahead and start writing those down. We'll go through them one at a time. So the first thing that we're talking about is a relation, okay? And a relation is any set of ordered pairs, okay? So if you have an ordered pair, technically that's also called a relation. Now within the relation is the domain and the range. The domain is the set of x values, okay, all of the x values. And the range is the set of the y values of the ordered pairs. Now, anytime that you see these pairs, they're always written in numerical order, okay? So it's pretty much from order from the least to the greatest, okay? All the times. Now, a function is a relation, so sets of ordered pairs, where each element of the domain corresponds to exactly one element of the range, okay? And that might be like, whoa, Mr. Grice, what are you talking about? Pretty much each domain has only one range that it goes to, okay? And we'll take a look at it this way, okay? So here's our domain. If I have the number 1, there's my range. Let's say that it goes to 3. So when you plug in 1, you get the answer 3. When you plug in 2, you get the answer 4. Okay? This right here is a function. That's good. Okay? But now, let's draw another one. The domain, there's the range. We've got the number 1. It goes to 3. We've got the number 2. It goes to 4. But you know what? It also goes to 5. Okay? That is not a function. Okay? Because right here, that 2 is going to 2 different numbers, and we can't have that. Okay? All right, so let's go through some problems. It says to state the domain and the range of each relation, then determine if it is a function. Okay, so the domain. The domain is right here. Okay, so all the domain is -5, 7, and 10. Okay, we're just writing those in order. Our next is the range. Our range, in order from least to greatest, -11, -3, 5, and 9. Okay. Now, is this a relation? Yes or no? Well, take a look at the 7 right here. The 7 goes to 9, but it also goes to 5. And we can't have that. So is this a relation or is this a function? No, it is not. Okay? Now, let's take a look at the next one. Now we've got a table, x and y. Okay, remember that x's are your domain. Okay, so one of the things that might be helpful is if we rewrite the domain with -8, -1, 4, and 6, which happens to be right here. So -8, -1, 4, 6. Now let's write the range. Let's do it in order from least to greatest too. So -4, -1, 5, and 7. So the range, -4, -1, 5, and 7. Okay? And now let's start drawing our arrows to see where everything goes. Well, -8 goes to -4. -1 goes to 5. 4 goes to -1. And 6 is paired with 7. Now, is that a function? Yes, because each one of these, each time we have a domain, it only has one range. And that's what we want. Where in the last one, 7 had 2 numbers that it went to. And that's what we can't have. Okay? All right, let's look at the next one. So we've got the first thing we have to do is write the domain and the range. So domains are all of the x's. So -3, 4, and 6. Okay. When we're doing this, we are not allowed to have repeats. Okay. And our range, all the other numbers, in order from least to greatest, 1, 2, and 7. Now, to figure out what everything lines up to, -3, 4, and 6, 1, 2, and 7. Here's our domain. There's our range. -3 and 2, 4 and 1, 6 and 2, -3 and 7. Okay, now look very closely at that because the -3 is going to 2 different numbers. And is that allowed? No, it's not. So is this a function? No. All right, and the next one. Now for this one, we actually have to find out what our ordered pairs are. Okay, so for A, it looks like it's 7. We'll call that 7, 7. B is -5, -4. C is 7, -5. And D is -3, 6. Okay, so stating all of the domain is the x's, so -5, -3, and 7. Next, we have to say the ranges, which is the y. So -4, -5, 6, and 7. So let's draw our little circles right here for the domain. -5, -3, and 7. And our range was up. Did you guys see the mistake that I made? I did not write 2 of these in order from least to greatest. Remember the -5 and then the -4. Okay, so -5 is paired with -4. The -3 is paired with the 6. The 7 is paired with the -5, but it's also with the 7. So is that a function? No, because that 7 goes with 2 different pairs of the range. Okay? All right, now that's when we're just given the numbers and the ordered pairs or a graph and we can kind of figure everything out. Now, the next is what we're going to do when we see a graph, if we can tell just by looking at it. and that's called the vertical line test. So the vertical line test is states that a relation is a function as long as no vertical line, okay, keyword vertical line, intersects more than one point at a time, okay? So what we're doing here is we're going to draw lines, but the first thing that it wants us to know is what's the domain and what's the range of each function, okay? Now, the domain, all of your x's, remember that this is our x's and this is our y's. So this line, is it ever going to stop? No. Okay, that's what the arrows are for. So it goes to negative infinity, and then to the right, all the way this way, it's going to keep going, okay? It's not going to stop. Even though it's going up, it's going to keep going up and out. So it's going to be negative infinity to positive infinity. Remember the closed brackets, or the open brackets, because it doesn't have an end. That's a reminder. And the same thing with the range. Look at, it's going to keep going down, and it's going to keep going up, okay? So negative infinity to positive infinity. Now, the vertical line test says that you can draw a line, a vertical line, and it's only going to cross one point. And you can do multiple lines if you want to. No matter where we draw it, it's only going to cross once, okay? We'll do one more, even right there, okay? So does this pass? Yes. So is it a function? Yes. Okay. Now let's look at the next one. Okay. The domain and the range, does it have an end? No. Okay. This thing keeps going on the x-axis and on the y-axis. There's no stop to it. Okay. And I'm only going to draw one line this time. Let's see if it passes. What do you think? It does. So is it a function? Yes. Now here's ones where we have to be careful. Okay. Looking at our domain, our x's, it has a definite beginning and a definite end. Okay. So it's going to be closed, and it goes to -6 to +6, because these are all the values that it can be within that range. Okay. Oops. All right. And now the same with the y's, okay, with the range from +6 to -6. Okay. Now, is this a function? Let's find out. Do a vertical line test. Up. How many times did it cross? 1, 2. Nope. Can't do that. It can only cross once. Okay. So let's look at the next one. Domain. Domain is your x. There we go right there. That's at -3. Can it equal -3? Yes. But then, where do these lines go? They're going to keep going and going and going and going and going. So it's going to go all the way to positive infinity. And so that's closed. And now for your y's, does it have a beginning or an exact end? It doesn't. So that's when it's going to be negative infinity to positive infinity. Now, is this a function? Well, if we draw a line right here, it is. Okay. But we have to be able to draw more than one just to check. And when you draw your other one, it crosses more than once, so the answer is no. Okay? Well, that's going to be it for Algebra 2, Chapter 4.6 Notes, Part 1. If you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Thanks for watching, guys.